Incorporated. I know we got a couple people who are still going to be logging on here, but we're going to go ahead and get started so we can stay on schedule. We've got a webinar scheduled here today for modern techniques for foundation rehabilitation. A little bit about what we're going to be covering today is going to be, there's going to be a one. Let me find myself here, guys. I apologize. Here we go. The webinar is scheduled to be 1 hour, and this is going to be a PDH credit. PDH credits will be offered for any attendees. Right now, you guys are all muted. All microphones will remain muted, and we will have a period for Q&A at the end of this presentation. Should be around 11:50 if we can stay on target. After the webinar is finished, you guys will receive a follow-up email. And in that email, we're going to have a link to a questionnaire form. If you do require some PDH hours, please go to that link and make sure you provide the feedback. A little bit about what we're going to cover today is going to be an intro to EagleLIFT, who we are, who I am, what we handle. And the big topic today is about settlement and remediation techniques. So we're going to discuss a little bit about the causes of settlement and the symptoms of settlement, specifically in buildings, also a little bit of infrastructure. And then we're going to get into the remediation techniques, types of repairs, benefits and risks, and how they compare to one another. Starting with EagleLIFT, just a little bit about ourselves. We were established in 1995. We are a general engineering contractor, licensed as Class A out of California, Arizona, and Nevada. We have 37 employees, 2 of which who are engineers, and our headquarters is based in Rancho Cucamonga, California, with satellite offices in Las Vegas, Nevada, as well as Hayward, California. The company is owned and operated by Colonel Donald Moody, retired Colonel Donald Moody, who was also an engineer in the Air Force. The services that EagleLIFT provides is foundation lifting and stabilization. The products we utilize is helical piers, chemical grout, or shallow surface stabilization and densification. We handle everything across the board from railroads, freeways, highways, infrastructure, commercial buildings, all the way down to residential homes. We also provide geotechnical engineering. We do site assessments and design for foundation stabilization and slab leveling. And again, we do dabble into the infrastructure repair. Sewer rehabilitation as far as lining, restoration, stabilization, and leak sealing. Our customers across the commercial, industrial, public works, transportation, residential, and government industries. And we've been doing this for a little over 20 years. Again, we were established in 1995. So diving into the actual topic of conversation, what causes foundation settlement? Now I know we're all primarily engineers. Oops, lost it, sorry. I know we're all primarily engineers who deal with this every day. But things that do cause settlement could be evaporation, transpiration, where tree roots draw water out of the soil, plumbing leaks, drainage, inferior foundation construction, inferior ground preparation, or poor soils conditions. Now, the majority of the things that we talk about there have to deal with water, either the introduction of water into soil or the drawing of water out of soil. Of course, you have other things like hillside creep, which might generate lateral movement on a structure, or consolidation of fill soils. But water is going to be something that definitely exacerbates the issue. So one of the things that we always recommend to clients is proper drainage and grading surrounding the structure that they have to sort of help mitigate the settlement before it begins. If you have a structure that's experiencing foundation settlement problems, the symptoms would appear in the following area. They would be inside the structure, which would be doors and windows that are misaligned, sticking or swinging freely. Obviously, if the floor slopes down or you have a cracked slab or there's differential settlement between 2 slabs, it's an indicator of either heave or settlement. Outside the structure, you'd find cracks in bricks and stucco or gaps around doors and windows. Usually in the garage is the easiest place to see something like that. If there's a basement, which here in California we don't have too much of those, but you would expect to see all of the same signs and symptoms as inside the structure, except where the basement goes underground, oftentimes you'll find water intrusion seeping through the walls. As well as in the garage. You can see separation around the door, cracked finishes, obviously cracked footings or different things like that could be a sign or symptom of settlement. Now, even though we talk about these being all of the symptoms of settlement, it's important to note that just because there's a crack in drywall or stucco or even the foundation doesn't necessarily mean it's a foundation or a settlement problem. It could be inferior foundation preparation. The rebar could be going bad. There could be a series of things happening that causes like a crack in the foundation. So when we send our inspectors to a job site or a potential job site, what we're really looking for is a combination of these symptoms, unless, of course, obvious sloping of the floor. If the structure is experiencing foundation settlement problems, other symptoms could be pooling water. This is more like warehouse applications. Pooling water, a big one is rocking slabs. When you have a forklift and you're driving it through a warehouse and you hit the transition between two slabs and it starts to rock or jump up and down, you get that rocking slab effect. And that's an indicator that there's a void that exists underneath that slab. And the void, like you see pictured here on the right-hand side, can result in the differential settlement of that slab, which will eventually crack the slab, and then it becomes a much bigger repair than if you handle it on the front end. Sinking or sloping slabs, separations between the walls and the slabs, cracking in walls, and cracks in slabs. All of those could be signs and symptoms of settlement. So we've got all of the different signs and symptoms of settlement, and we've got some of those causes of settlement, but what about fixing it? EagleLIFT approaches foundation settlement with foundation underpinning, which is a process of strengthening and stabilizing the foundation of an existing structure. Underpinning is accomplished by extending the foundation in depth or in breadth so that it either rests on more supportive soil or distributes the load across a greater area. Now, it's kind of a mouthful there, but that leads us into the different types of underpinning, which is really what I wanted to touch up on during this webinar. Underpinning can be accomplished by any of the following, which would be extended footings, sometimes also called grade beams, foundation replacements, compaction grouting, or caissons. Now, all of those options for foundation repair or foundation underpinning, I apologize, all of those options create a sort of paradigm that I like to follow for all types of foundation repair. You can see here from the image, from the left to right, that there's many options available for foundation leveling and stabilization. As you get to better or more thorough repairs, of course, the costs become more exponential. So in understanding that we wouldn't ask a homeowner to pay $700,000 to fix a home and stabilize a hillside, it's sort of our job to move along that paradigm and find the best value in the products and services to accomplish whatever it is the client is trying to do. That being said, when we don't go to that far right of this paradigm and ask the biggest, most invasive and expensive repair that exists, then there's certain risks and benefits that are provided for each type of repair. So on the far left, you see that they have the do-nothing approach, and obviously that's don't handle anything, all the way to cosmetic repairs, which is that second one. You get pressure grouting, compaction grouting, and all the other stuff we're going to talk about. You see it becomes more invasive, it becomes more expensive, but it becomes an overall better quote-unquote repair. Except for that do nothing. All of us know that if you do nothing to solve or mitigate foundation settlement problems, ultimately you're going to wind up with a bigger scope and a much bigger project at hand. So ultimately, I guess do nothing costs the most. So the first thing I wanted to touch bases on was compaction grouting. Compaction grouting is the process of essentially injecting a concrete cementitious grout, cement sand slurry, or structural polyurethane into soil with the idea of filling voids and strengthening or densifying the soil. It's got a lot of pros because it addresses weak soil issues. If you use a structural polymer, then you want to use a closed cell polymer. And when you do that, they can operate and seal against wet environments. As a matter of fact, EagleLIFT has a long history of doing a lot of leak sealing projects for manholes, culverts, drainage areas, different things like that. This particular type of repair resists axial compressive loads, and it is non-invasive, quick, and reliable. What it addresses is weak soil issues or water that's saturated with soil. It's a quick in and out, and also one of the most cost-effective means of strengthening soils and lifting foundations, buildings, and slabs back to level. Some of the cons is that there's limited install depth, specifically for the structural polyurethane. If you do an injection, the chemicals mix at the tip of the gun. If you see in the picture, they're injecting through a tube down there underneath the footing. Well, the chemical reaction begins to occur right there at the surface level, which means if we're trying to go down 40 feet, 45 feet, then the polymer reacts and fills up the tube I'm trying to inject through. Other cons is that the soils that are bound to the polymers are still subject to change. That means if you're injecting into a highly expansive soil, caliche clays, Libby gulch soils, anything like that, it doesn't become the best repair available. Also, it doesn't address really any other loads. This is kind of a touchy subject. I'm sorry?
I got the URETEK one that's going to be on like in an hour.
I apologize, I can't hear you, but I'm going to go ahead and keep going, boss, so I apologize. It's kind of a touchy subject. I'm sorry?
We're just going over that.
Just make sure you're muted. Make sure you're muted. Are you just? Oh, yeah.
How do I mute this?
Sorry about that, folks. I'm going to cog.
Apologies, guys. That was a error on our half. One more time. It's kind of a touchy subject to say that it doesn't address any of the loads because structural polyurethanes, as they permeate through the soil and sort of bind all of the soil together, has been used in many hillside stabilization applications through Caltrans. So it's, again, kind of touchy. The only other real con to it is that it's impossible to specify exactly how much product will be used prior to the start of work. We have calculations and soils testing that will give us a lot of information about how much product that you'll end up using, but you could spend $50,000 in soils testing and I will never be able to tell you that we're going to use 50,281 pounds of polymer. It's just something that's impossible to specify. You'll get a pretty good range, maybe within 10%, but it's just not something that you can specify to an exact number. The next repair that we like going through is called push piers. Push piers are the use of a side-loading bracket that attaches to the bottom of the footing, and steel tubes are then hydraulically driven through the soil until they encounter competent strata. It pushes up on the foundation footing in order to drive the steel tubes down. So you're relying on the weight of the structure to get the depth of installation on your push piers. Once a stable soil is reached, or once you hit competent strata, the home is lifted, or the building, and significant building loads are then transferred down to the stable soil. So what that means, if I got really bad soil, I'm basically taking it out of the equation and picking the house up on stilts. The pros to this is that it provides the best possible lifting opportunity. Provided the piers are designed the right way, design loads can go all the way up to 110 kips, no issues whatsoever. There's a lot of different companies that utilize this, and it's becoming a much more popular repair system similar to helical piles that we'll talk about in just a few moments. Push piers are easy to install. There's no heavy lifting. Usually don't need a tractor or an excavator or anything like that to do the installation, which means we can install it in tight conditions. They can definitely support heavier loading. I still haven't seen a building yet that a push pier can't pick up, unless, you know, skyscrapers. Push piers also resist axial compressive loads. One of the cons being that it does not address any other loads other than axial compression. All the push piers that are designed out there use slip couplers, slip sleeve couplers, which means if you push or pull up on those tubes after they've been driven into the ground, barring skin friction of soil on those tubes, you'll be able to just pull them straight up out of the ground. Another con is that push piers do not have an ICC approval. Most engineers look for ICC approval on any designs or significant, well, really everything. What is happening, however, is that IAPMO and other companies such as PEI are doing standardized testing on push piers. They are similar to the ICC. They are nationally accredited and different things like that. It's just not specifically the ICC. Currently, there's 3 different types of push piers that have all of the appropriate testing and the ESRs released for them, and that would be the safe basements piers, the foundation support works piers, and the ramjack piers. Another con is that you cannot use push piers on lightly loaded structures. Recall that because you're installing the piers and relying on the weight of the structure to get your depth, if I were to put it on an addition or a single-story wood frame home that has wood siding, I'm not getting my piers down more than maybe 10 feet. And if I don't get the pier past 10 feet, design-wise, we know the building code requires us as engineers to assume that the upper 10 feet are just free-floating, essentially. But even barring that, if you don't go past 10 feet, you're not really stabilizing anything. Another con for the push piers is that they cannot be used on crumbling foundations. Because you're attaching the bracket to the underside of the footing, obviously a footing has to exist, and it has to be in structurally sound condition. This is why engineering is so important for every push pier application in order to check that stuff before we jump on the job site and start digging holes. One more thing to note is that each pier should be individually driven, never one right next to the other, and you do that to maximize the home's loading onto the pier. If you push 2 of them right next to each other, they would influence each other on the footing, so you get just a little bit less depth. After each one is individually installed, you can see they put all the hoses that attaches each pier together using the lift stations, and then we lift in uniform. All the piers lift at the same time. And we do that to reduce the stress on the building and minimize interior damages. Helical piers are basically the same thing as a push pier, but instead of slipping your L bracket in and then using the weight of the structure to drive the tube through the soil, instead you're going to screw the helical blades down into the soil first to target depths and target torque for stability as designed by the civil or structural engineer, and then you attach the bracket, load everything together, and then the structure is lifted. The cool thing about helical piers, as engineers design them, is that they can pick up 1,000,000 pounds if they had to. You've got helical piers from as small as 1.25 inch thick RCS shaft, all the way up to, I've seen 16 inches, 24 inches thick in order to pick something up. And that type of solid, rugged steel is just incredible and provides phenomenal lifting opportunity. You have the ability to install it in tight conditions, and one of the biggest pros is that they resist both axial and tension loads. And they also, there was a study released recently, if you guys are interested in it, I can get it out to you, that shows that the helical piles also resist minor lateral loads when used in a vertical application, which was kind of a cool thing. However, if I were to take that vertical application, turn it sideways onto your x-axis, and then install laterally, because they have tension resistance, push piers also can be used as a tieback anchor for lateral protection on basements, on retaining walls, anything like that. My personal favorite is to put a whaler beam between them, and then you can actually torque them and straighten the walls up. So helical piers has a lot of different applications. They can be used as a designed to strengthen the footing or deepen the footing, essentially. if you're planning on putting an addition on a home, because they don't rely on the weight of the structure. You just apply a ghost load. You know how much load is going into that addition. You design it accordingly, sink the piers, and then do your addition. They can be used to hold down guy wires. They can be used for street signs, different things like that. It's a very diverse application. However, it does have some cons as well. When looking at a structure, you have some limitations based on access. If you've got a home in Hollywood Hills that has a cliff face on the back half, it's going to be super hard to get an excavator back there. So it becomes a little challenging in order to build out the back area and get those helical piles installed. Costs increase exponentially with greater depths. Once you start penetrating down 20 feet or so, you can't have an 1.25 inch shaft anymore, an 1.5 inches. Now you're looking at 1 3/4, 2 inches, 2.25 inches. You have to start increasing the thickness of the shaft, adding more blades, the size of the blades, in order to get better strength from the piers that resists not only the tension load and the compression load, but also the torque load that you're putting on the pier in order to screw it down into the soil. We had a project out in Vegas, actually, where there was a misdesigned pier, and it was the coolest thing, actually, to see the shaft had completely twisted. It spiraled all the way up from the top. We actually wound up having to change out the piers, obviously. But that being an example of costs needing to increase by having a thicker pier. Once again, your piers cannot be used on crumbling foundations. There has to be some amount of strength left over in your footings. If they're spalling or if they are just flaking away and they have no structural strength left, then your repair, yes, it will help deepen the footing, but that concrete is still going to crack and the home is going to continue to experience failure. And finally, cons. It says impractical use in extreme depths. That's not entirely accurate. It's more super cost prohibitive to use it in extreme depths. When we talk about grade beams and deepened footings, what we're talking about is excavating out the original footing and then putting in a newer concrete form. We'll dowel it into the original footing to create a bigger, stronger footing that is capable of sustaining heavier loads. Also, it ends up going down deeper into the soil, which means the soil should have less of an effect on the grade beam. The pros is that it can support heavier loading, and they can be used as an upgrade footing to support a second floor addition. If you're sitting on strong, stable soil and you don't want to build a second-story addition on a 12-inch footing, which you're not supposed to do anyway, then you can put a grade beam down there, and it should be compliant in order to make the footing bigger without having to tear out the old one or anything crazy like that. It is designed to resist all surface loads, axial, lateral, dynamic, and can be used in conjunction with soil stability products and processes. See down there in the cons, it says does not address settlement by itself twice. That's the point that we're trying to hit home here. Settlement, as we discussed with the water coming in or out or ground preparation or anything crazy like that, is not addressed by just putting more concrete down there and making the footing stronger, because the soils problem still exists. So what you can do is sink those helical piers that we were talking about with all of the design already taken care of to target depth and proper design, and then you can actually tie it with a new construction bracket directly into the grade beam that you're building on the side of the home. If you do that, then essentially what you're getting is a deepened footing without all of the extraneous costs of excavation and spoils and different things like that. And you see that actually down in the cons list here that, yeah, you have higher costs for excavation and spoils when you take soil out and replace it with concrete. It's labor intensive and it damages landscaping. One thing that we have experienced as contractors is that oftentimes with homeowners specifically, commercial businesses or whatnot, they're not technically inclined. Once we're done on the job site, there's still going to be some cleanup that needs to happen. Plants need to go back, drainage grading needs to be taken care of. Whatever their finishes are going to be to make it look cosmetically beautiful is something we generally don't handle, and that's why this is listed in our cons section. Foundation replacement. Makes sense. If my footing is broken, replace it. For foundation replacement, we excavate a trench on the side of the footings, usually in 10-foot sections. We try not to undermine an entire wall all at one time because obviously that could have a detrimental effect if there's no other type of underpinning to support it. Then we detach the sill plate from the footing, and a temporary means of lifting the framing is installed. And once the footing is demoed out, again 10-foot sections usually, and a new footing with proper reinforcement is installed, we'll pour the concrete in, framing is lowered back down onto it, and of course attached with the anchor bolts to the newer footing, and you have a brand new footing. The pros is that it provides an excellent leveling opportunity. If the home has vertical displacement or differential settlement, it is an excellent opportunity to lift it back up. Again, best opportunity is using those push piers, but this one provides a pretty spot-on opportunity. You have the ability to bring the structure to code compliance. You know, a lot of homes in the LA area and California were built ages and ages and ages ago and currently are not in code compliance, and honestly a lot of them are falling apart. So this provides, if you spend the money to replace the foundation, it's a great opportunity to just go through, do the seismic retrofit, and just bring the structure overall up into code compliance. Now, hey, another pro, seismic retrofitting. It can also be used in conjunction with soil stability projects. Once again, or products. Once again, we can sink those pre-construction helical piers and put the new construction caps on the top of it, and then pour the footing on, and you have essentially a deep foundation system without the costs of trying to dig everything out directly underneath that footing. Probably the biggest pro to this is that it addresses crumbling footings, spalling footings, or anything like that. If your rebar is wearing out or corroding, and if your footing is just in bad shape, if it's not doing well, this repair will take care of that because you're putting a new footing in there. So as engineers over here at EagleLIFT, when we look at a project, yes, we're looking at costs, but also what we're looking at is what has to happen. For homeowners, business owners, anything like that, if they look at a problem, they want to deal with it, and they want to deal with it once. So we don't recommend the steel underpinning systems if you have crumbling footings. Usually we would recommend something like foundation replacement in conjunction with. Cons is that, again, your costs increase exponentially for spoils and excavation, and repair are severely limited by the condition of the superstructure. That's true of all other types of foundation leveling and stabilization products and processes. However, especially true of foundation replacement because you're going to be picking the house up by the framing. If the framing is in no condition to be lifted, if it's rotting, if it's got termites that have affected it over the years, if you've got anything like that that affects the superstructure, then it's going to definitely change the options. You're not going to get a house up like you see pictured here on the left-hand side. You're not going to be able to pick it up because it'll just kind of crumble and fall apart. Finally, caissons. This is probably the biggest, best repair out there. It's also the most invasive and generally most expensive. What it is that an excavator is used to drill a hole next to the existing foundation to a depth and width determined by a geotech engineer. The depth is assumed to have several feet embedded into bedrock or competent strata based on soils testing specifically. After excavation, an intricate design of rebar, of a rebar cage is dropped into the hole, which is sometimes belled at the bottom and cleaned if called out by the PE, and then concrete is poured from bottom to top. When the concrete is cured, a grade beam is constructed to connect the series of caissons along the walls and attach them to the original footing. So you can see there's a lot of work that goes into this. The pros is that it provides an excellent leveling opportunity. Again, the ability to bring the structure to code compliance and the ability to install seismic retrofitting options. It can be used in conjunction with soil stability products and processes, but that's exactly what this is. And it does address crumbling footings. again, sort of the biggest, baddest repair out there is a huge 4-foot wide caisson going underneath a house. The con is that the costs increase exponentially for spoils and excavation by a lot. Obviously, the wider the caisson is going to be, the deeper it goes, the more spoils you have. And also, the repairs are severely limited by the condition of the superstructure. Apologize, these slides do not seem to have transferred through well. That's my fault, actually. Caissons do address settlement specifically. Generally, they are cost prohibitive completely. A good way to estimate how much a caisson project is going to cost is about $350 a lineal foot. That's depth and width and length of the wall. So, I mean, adding those numbers up, obviously it's just a huge expense. The other con really for caissons is that one of the things that we actually see a lot here at EagleLIFT is somebody will spend the money to sink the caissons, and they've spent a lot of money on geotechnical testing and different things like that. But if the caissons are not sent deep enough, if bedrock is 20 feet down, and we saw something over here in La Habra a few months ago where bedrock was 22 feet down, and the contractor came in and sank it down only about 16 feet. So all of that extra weight, that extra 150, 250 pounds just created an anchor, literally adding a ton of weight onto the bad soil, the soil that's at that point couldn't support the existing loads. And then you added a ton of weight on top of it, and because you attached it to the footing, it just acts like an anchor and just pulls the house down the hill. So it's the biggest, it's the baddest repair, it's the Lamborghini of foundation stabilization and leveling. But at the same time, when a caisson fails, it fails. So it's super high risk for the money that goes in. It's just one of those things. I wanted to go through a few projects where we utilized a couple different types of repairs, the ones that EagleLIFT does a lot. There was a Courtyard Marriott out in Phoenix, Arizona that had a garage ramp that had settled a little over 3 inches. They utilized the URETEK method, which was the compaction grouting that we had discussed, but we use a structural polyurethane. You see pictured on the left-hand side in the after picture. We were able to densify the subgrade and lift the ramp back up to level. We worked with the Courtyard Marriott team for the facility access. The hinge slabs were about 32 feet by 25 feet, and they were more than 12 inches thick. We were able to pick everything up. You can see from the before to the after. It only took about a day to do this entire project all the way across. It was a largely successful project. As a matter of fact, if you look it up on YouTube, URETEK Courtyard Marriott, you can see the video of the entire URETEK process where we drilled very small holes, provided the injections until the polymers came out, allowed the reactions to occur, and then lifted the ramp back to level. This was as compared to the alternative, which was demoing out the entire ramp, shutting down the access for over a month so they can pull it out, strengthen the soil, lay a new foundation for the slabs, and then pour the slabs and wait for it to cure before opening it to traffic again. A lot more costs and spoils, excavation costs, waste, etc. Time shut down. That was the important things to the guys at Courtyard Marriott, was that we were in and out in a day, and the project was solved for a fraction of the costs. A great helical pile application. Again, we talked about those new construction brackets tying into slabs. There was a Sunnyvale, California had Fair Oaks West Apartments. There's a project actually that came up pretty recently. The site was located in the Santa Clara Valley, which has a broad alluvial plain between Santa Cruz Mountains southwest and west, and the Diablo Range to the northeast. The property owners decided to have seismic upgrades added to all 16 structures in the complex, and helical piles were selected as the best choice for the upgrades, for both vertical and battered piles being included in the upgrade design. Each apartment building had been constructed over a partial subterranean parking level, which you can see on the left-hand side, or sorry, at the top of the screen. And they were all wood frame structures. There's some minor settlement that had happened, but there was nothing significant. We did some soils borings in several locations, and the the depths ranged from 6.5 to 40 feet. We found mostly sand and medium dense clayey sand along some areas, and then we found some silt and gravel in the others. The piles that we used with McLean-Dixie Power Systems Civil Products Group were all 1 3/4 inch round corner square bars. The leads had 8, 10, 12 blades, and the required load was 40 kips. The leads were used for the battered piles had 2 different configurations actually, which was 10, 12, and 14, and 14, 14, and the required loading on those battered piles was 70 kips. 1 tension load test on a battered pile was required and completed successfully, and the new construction caps were connected to each pile. The EagleLIFT crews completed the work for each basically 1 building per week, so the entire project was successfully completed in 16 weeks. So it's kind of a cool tension compression application, plus the new construction application that you can see here. It was the project scope was very large and kind of a neat thing to be a part of. I think we have a couple of case studies on it. If you're interested, again, you'll be able to email us later and we can shoot you over that information. In San Diego, California, we were able to use URETEK polymers as a deep injection, which we'll talk about in just a minute, in order to level and stabilize a residential home foundation. In San Francisco, one more thing about our steel system underpinning. This is a push pier project right here, I believe. Nope, this is a helical pier project. Apologies. The thing about our foundation underpinning is that it's a below-grade solution. If you use steel underpinning that attaches to the bottom of the footing, then once you're done, you backfill, obviously compact in 6-inch lifts all the way back up to the top, and you can't see the piers anymore, which is half the point. For historical homes like this project up in San Fran, where it's very important to preserve the image of the outside of the home, or any historic homes or anything like that, because it's an underground solution, takes time to put in, yes, but after you're done, you can't really see anything, even though you have stabilized and leveled out the structure. This is our solutions value grid, kind of like that paradigm that we were talking about. It talks about the loads that each one of our product supports or does not support, plus the value that you get on each one of the projects, or sorry, the cost to put in each one of the repairs. So this is one grid that we were talking about with that paradigm about the cost of doing nothing versus spending $250,000 to stabilize your 2,500 square foot home. The other thing is determining which repairs are appropriate. Obviously, each different type of product will be ideal for certain situations or will not handle certain situations. So this sort of grid here is the way that we help determine based on what the client is trying to accomplish. If they want the home leveled, great. If they want the footing fixed, great. If they want to put a second story on their house, great. Each problem you have on the left-hand side versus solution on the right will show you which repairs we kind of pick and choose to design our repairs based off of. I wanted to explore compaction grouting a little bit more with our structural polymers. I'm going to kind of breeze through this a little bit. I realize we're getting a little closer to our time. The compaction grouting with polymers, structural polyurethane, it's very lightweight but very strong. The URETEK method, which is done directly under slab, can be used for pavement lifting, soil stabilization, subsurface soil compaction, and water displacement. URETEK is a worldwide company. It was developed in Finland a little over 35 years ago, and since then has branched out to 32 different countries. The method itself utilizes a roughly 4-foot grid pattern in order to stabilize the structure and lift any slabs back to level. During this process, you stabilize the soil, strengthen the soil beneath that slab, fill any voids that might be resultant of the differential settlement or erosion or anything like that. We underseal it at the same time and then provide that lift. The gridded pattern has a little bit of overlay, so it ensures that the material addresses the affected area and has consistent distribution with highly improved weight-bearing capacity. This moves us to the deep injection process. However, whether you're using the URETEK method or URETEK Deep Injection, we use the same two-part structural polymer. Soil stabilization at a shallow surface, which is anywhere between 0 and 40 foot below grade, densifies and binds the soils together. Remember, it goes into the soil as a liquid under low pressure, permeates through weak soil, and lensifies through the voids in the soil, fills the voids, then creates a chemical reaction that will bind it all together and strengthen it, and then level whatever it is you're injecting directly underneath, or lift, start out to level it. The deep injection process takes the same grid pattern for URETEK method and puts it on a z-axis. So we're injecting down into the soil, roughly 4 to 5 foot on center injections. We inject through some tubes, and essentially what we're trying to do is create a stable matrix of soil beneath the structure that you're trying to stabilize. So it's in situ stabilization of soils at depth. Multiple depth vertical injection, vertical and horizontal injection approach is the way that we do that. And lower strata injections help anchor the upper strata injections for increased densification potential. The increased densification creates upward pressure, and from that we get our lift, I believe up to 5 tons. The URETEK polymers allow for flexible use for lifting, sealing, void filling, and soil compaction. And once injected, the polymers expand up to 20 times their liquid volume. They're environmentally inert. That's a very important thing about the URETEK polymers. There's other polymers that exist out there, but our polymers are environmentally inert. As a matter of fact, we have our NSF61, so we can inject on, near, or around potable water. It's highly controllable and structurally stable. We can usually be accurate within about 1/10 of an inch. We have a patented 3-step application process, which starts with subsurface application into the problem zone via direct injection tubes. We utilize a proprietary 2-part expanding structural polymer. And also we monitor the application with laser levels, zip levels, dial gauges, and or conventional levels. Here's a little bit of information regarding our structural polymers, the composition being a resin and a hardener, the mixing ratio 1:1 directly. It's an exothermic chemical reaction that generates CO2 gas, and the gas causes expansion of the material, creating the lifting pressure and strength. It's very, very fast. Again, if you guys can check us out on YouTube, they have a couple of videos on the expansion of our URETEK polymers. It takes only a couple seconds, and you can either retard that reaction or you can increase the reaction aggressively by using either an aggressive polymer or a different type of polymer, or the temperature of the injection that you do, because heat would be the catalyst to the chemical reaction. And once again, yes, the polymers are NSF61 certified, and it's the only patented hydro-insensitive polyurethane foam that has that certification. It has a very rapid cure, which is very, very important for our Caltrans or our roadways, municipal departments, or much like the driveway ramp that we looked at with the Marriott. We've done projects for Walmart where this was super important. It can support loads after 15 minutes. It reaches its full strength after 24 hours, but over 90% of its strength is within the first 15 minutes. What this means is that by the time we're finished cleaning up from our injections and from our projects, we're good to take down any traffic control and open the roadway, highway, freeway, runway, whatever it is we're injecting underneath to traffic again. It's a rigid structural polyurethane is created as the material cools. There's been a lot of testing on the polymers, which again is also available. If you guys are curious about that, you can shoot us an email. It has the compressive strength, tensile strength, shear strength, different things like that. Most notable, though, is testing for ASTM 1622 and 1621, which is the density of the product versus the compressive strength. And the relationship between the two is that the more dense the product gets, the stronger it becomes. Most final applications that we see reach final compressive strengths that range between 800 to 1200 psi. But the confining pressure that allows the polymer to become more dense allows for a much stronger finish. The polymers that you see in its strongest state is through your deep injection tubes after injection. And when you shear the tubes off at the surface level, you can actually see it in an almost crystallized state, which has been tested at about 5,000 psi of strength, as strong as or stronger than concrete. Again, it's hydro-insensitive, so it contains water-insoluble dilutants. It can be injected into wet soils and even standing or flowing water. Now, we're not talking like something shooting out 45 psi because it will displace the material before it gets a chance to set. But once again, if you look us up on YouTube, a lot of great public works applications about sealing leaks and taking care of culverts and drainage ditches and dams and levees and different things of that nature. Probably the biggest competitor, I guess, to URETEK would be the cementitious grout, because they're both the same process. You're injecting cementitious grout or you're injecting a structural polyurethane. List of advantages for our polyurethanes. It's our salesy side, guys. Just kidding. The application of a cementitious grout, mud jacking, essentially, is anywhere between 2.5 and 3.5 inch holes diameter. Whereas when we inject our structural polyurethane, you're only looking at 5/8 of an inch. This is important not only cosmetically, but also structurally, because we're not making Swiss cheese out of concrete slabs. Concrete mixes with water, so it doesn't have any hydro-insensitivity, whereas the structural polymers have full hydro-insensitivity, no reaction to water. As a matter of fact, when you inject underneath a freeway, oftentimes if you look out on the side of the road, you can see water pumping out from the underside. When you use cement sand slurry, the compressive strength is overall variable, whereas our structural polymers are generally 60+ psi. Lifting accuracy, when we use a slower acting foam that under a lower temperature, so it sort of retards that reaction, it creates a very, very slow lift. With that, we're accurate within about 1/4 of an inch, whereas when you use cementitious grout, it's only about 1/2 inch. The biggest difference between concrete and polyurethane is that your concrete weighs 120 pounds per cubic foot. It's a lot of weight. So even if you fill the voids, even if you get the lift that you're looking for and you accomplish your project, now you're adding literally a ton of weight onto soil that's already bad. This is versus injecting polymers, which range between 4 and 20 pounds per cubic foot of weight. And again, for your concrete, it takes several days for its cure time. For our polymers, reach 90% of its total compressive strength within the first 15 minutes. There's another project that we did here. You can see a dip in the roadway on the right-hand side on the top. Major, major dip. We just did deep injections below your base first in order to consolidate the bottom half, and then shallow injections at the top. We got perfect level out of that roadway. This would shut the street down and then open it back up within a day, as compared to tearing the whole thing out, compacting everything, filling the void, well, not filling the voids, and pouring dirt, and then repouring new concrete and or asphalt, which has a lot of time, a lot of downtime, as well as a lot of excavation, a lot of spoils. Overall, most of the time we come in at under half the cost of ripping and repouring something out. And again, that time is the biggest element when it comes to most commercial uses or public work uses. Bridge approach and departure slabs are other types of infrastructure that we handle all the time, usually through Caltrans, but a lot of municipalities have this issue as well. And infrastructure such as manholes that have moisture infiltration. It could be through cracks, could be through vehicles driving over the top of it that separates the joints. Anything that allows moisture's intrusion on the inside will actually drop someone into the manhole to perform lateral injections. We'll inject the adjacent lines on the outside, obviously. We'll put a bladder into any adjacent lines to ensure that no polymers infiltrate into the sewer itself. Then if it's in a condition to be lifted, we'll actually lift and level the manhole. If you guys are curious about the infrastructure applications of the compaction grouting with structural polyurethane, we are going to be having another webinar for you guys. It's going to be called Reclaiming Aged Infrastructure for a Trenchless Revolution. This will be done on Friday, April 15th from 11 to noon. It's going to be specifically about how we handle infrastructure projects. And again, we will be offering PDH credits for this presentation as well. You can connect with us on Facebook, LinkedIn, or YouTube. We are EagleLIFT and we are URETEK. Look up EagleLIFT. We've got all of the information out there. There's a lot of really, really cool videos on YouTube if you guys wanted to check that out. And this concludes our presentation for today. My email is listed there, kolson@eaglelifting.com. You also have my mobile number and a link to our website if you wanted to find out more information. We're going to go ahead and unmute everyone and open the floor for some Q&A. So if you guys have any questions, comments, concerns, feel free to open up.
Well, quick correction on that. Actually, if you would like to submit a question, please use the questions area within the webinar tool. You can see it's got a little bit of a little plus sign next to it. It's called questions, and from there you can submit your questions. We actually already have a few, and so I'll go ahead and going to ask them. So the first question we have is, can push piers be used on single-family homes since they cannot be used on lightly loaded structures?
Yes, it depends on soil conditions beneath the home as well as how the home is built. Residential homes, single-family homes, is actually one of the most common uses we have for the push piers. Usually wood frame and stucco structures. Now, if you do that up in San Jose or specifically up in the city of Novato, which is Northern California, we drive these push pier tubes down 115 feet for each pier that goes down into the ground, and that's just based on your single-family application. This is also versus like Huachuca, Arizona, where we had single-family homes that you only went down 3 feet, in which case it doesn't work out super well there. So it does depend a lot on the soil's conditions as well as how the home is built, but yes, it is absolutely an application for push piers.
All right, so next question is, how can these piers be used in seismic retrofit type projects where you have both vertical and lateral loads?
We would get a geotech engineer to do a lot of soil testing. It would have to be the helical piers. Push piers are not designed to resist lateral seismic, any type of loading other than your axial compressive loads. Helical piers, however, because they tie usually in lateral loads, in lateral applications, they'll tie through the slip plane a minimum of 3 to 5 feet, which will help anchor the building to the hillside so that it's not going to move. You attach the helical piers to the footing using your red heads, usually not the epoxy, usually the mechanical anchors. And because the whole system ties together, you just have to get the design and a little broad of a question, but that would be essentially the short answer.
Great. How can you determine adequate coverage with the Crick reaction limiting material spread, i.e. increased flows of polymer?
Okay, we prefer to do a lot of testing on any application of polymer, not only for depth, but to find out where the void exists beneath the slab. So if you're doing a void fill or something like that, what we'll do is create a series of holes and then inject through one hole until it comes out through the other hole. Again, it's going to get kind of a long answer here, but that ensures that we have the coverage. When you inject through one hole, it comes out the other hole in a void fill application. However, for lifting or deep injection applications, because it lensifies through the soil, The design is, let's say I've got a standard injection temperature and a standard type of polymer that's not super aggressive or not a retarded reaction. So just your standard through and through. The coverage of that polymer is about 4 to 8 feet. So when we do our injection pattern, in diameter, 8 feet in diameter. So when we do our injection pattern, I would inject every 4 foot on center, so you have a little bit of overlap on the in-between. Now, when you get into higher plastic soils or highly expansive, dense clay soils, again, the polymer doesn't become the best repair there because it doesn't permeate through the soil. Sands are perfect. You create sort of a solid rock using the polymer when you inject through it. But caliche clays or Libby Gulch soils, we don't even try to inject through because it's already so dense that you can't strengthen it. You can't really bind it together.
All right. Is this product, will it work in beach areas with salt water? Is there any concerns with salt water? And I believe it's referring to the polymer, but I guess it could take into account both the curing and the polymer.
Well, to answer the question, yes, for both of them. The design consideration would be the galvanized steel. The push piers can be triple hot zinc dipped and galvanized in order to resist corrosive soils, so that it doesn't break down. The polymer, salt in the sand or the air, the atmosphere, has absolutely no effect on the polymer whatsoever.
Okay, the next question is, how do you control the expansion that provides the lift that will occur with the polymer?
The injection of the polyurethane is done not just, imagine a guy squeezing a gun and shooting polymer into the ground. He doesn't just keep squeezing it until we get the desired result. What they're doing is they're injecting, and the injection pattern will change based on soils conditions and type of polymer, 10 on, 5 off, 20 on, 10 off, et cetera, et cetera. They call it feathering the injection. So what they're doing is they're allowing that chemical reaction to occur to densify the soils and create that base, and then they're continuing to inject. So not only are we using less product, but it creates a very, very slow, accurate lift at the top level. As far as controlling the expansion, you create a base to lift off of by injecting deep first. Once you've got that solid base, the polymers on the in-betweener become more dense, and as they become more dense, they create more upward lifting force. So the deeper, essentially the deeper you go, the more product you're going to use, because you can't control where it expands to, but you can control what happens on top of that.
Great. Next question is, why can't you use battered push piers for seismic?
You can. We've done it before. I don't like doing that specifically. It's personal preference. They don't have a whole lot of lateral resistance, and you can batter the push piers by pouring concrete down the tubes once you finish driving the tubes down, and then perform the lift and attach the pier to the footing. But if bedrock shakes and moves, the competent strata that the pier has embedded in, which may not necessarily be bedrock, if that shakes during a seismic event, the pier loses a lot of its overall integrity. So it's just not a preferred remediation method of mine.
Okay, can URETEK be used to stabilize liquefiable layers to eliminate liquefaction potential?
Absolutely. The polymers were actually presented at the 6th Pacific World Conference as a remedy for liquefiable soils. We've done a lot of projects like that, and it's very, very effective. Where it doesn't become effective is where it goes down beyond 40 feet because we can't inject that deep. But we've actually had a lot of interest in people who, if I had to inject 60 feet down, they were going to excavate the top 20 so that we can inject the rest of the 40. But yes, absolutely, it is a perfect remedy for liquefiable soils.
Are combination exterior turn-down wall foundations and interior slab settlements addressed with a combination of repairs, e.g. helical and push piers on the exterior boundaries and interior slab polymer, soil jacking / stabilization? Are expansion soil slab settlement remediations better resolved by piers or soil jacking stabilization with regards to expecting future expansion cycling?
Great question. Yes, a combination of products can be used for interior slab versus exterior perimeter. As a matter of fact, that's something we deal with all the time. Any interior bearing walls would require a deep injection of the URETEK product if you wanted to do polymers on the inside, whereas the slabs themselves could be void filled just at the surface level, which makes it much more cost effective than cutting out the holes on the inside of the house and then slipping piers underneath the footing of the interior bearing walls. Now, as far as clay soil expansion and expecting future expansion is concerned, that's a very difficult conversation topic. What we prefer to do is level everything out using push piers and or helical piers. I personally prefer helical piers during clay soil type applications just because it anchors down into the soil with the target torque and depth, and it doesn't have any of that movement. But what I would not do is shoot the polymer in and keep it sort of fill that void so that the soil, as it moves up, it'll push on the polymer will push on the footing, and then the footing will pull up on whatever you got. The helical piles, if you anchor them into the side of the footing with your red heads, again, usually a mechanical anchor, not an epoxy anchor, it'll help provide some resistance to that upward motion. But if you get a super strong clay that's going to pick it up, you're just going to crack the footing with your helical piles. So we prefer to pick it up as high as it needs to go or it's going to go, and then stabilize it from there.
Okay, great. Does the polymer push the soil away from the injection zone, supporting the structure based on the structural integrity of the polymer itself?
Largely depends on the type of soil you're injecting to. The more permeable soils you have, if it's a sandy soil, silty soil, even soft clays, it's not actually going to displace the soil. It's going to bond with the soil. It's going to bind with it, strengthen it. But the more you move into a heavier clay or a medium dense clay or anything else like that, the more it's going to displace the soil and push it and push against it and all that fun jazz. We had a void filling project out in Stockton recently where they had just a large collapse on the side of a house. So we injected at depth and it wound up pushing the soil up because it was a medium dense clay, and actually leveled out the whole thing and then ultimately bubbled it, but that's what they wanted us to do with it.
Okay, and this is the last question. So one moment. So you mentioned that a couple of the applications do not address settlement by itself. How do you address the settlement?
When you do foundation replacement or grade beams or anything like that, which does not directly address settlement, what it does address is the condition of the footing. You can level out the house. You can level out the framing. I guess that's misspeaking. You can level the framing of the home and then pour your new footing to level. But in order to stabilize against further settlement, I would drive down those helical piers with the pre-construction brackets to create a deep foundation system. Or you could do concrete mini piles at that point, or caissons, or any other combination system. But if I replace the footing of my home, which is settled because the soil is too weak, I have a new footing, I have a new foundation, but I haven't addressed the soil issue. So you would want to do that in conjunction with another type system, whether it be helical piles or concrete piles or caissons or whatnot.
Okay, great. Well, that's the end of the questions that have been submitted. If you want, we can wait a couple more minutes after we've let everyone out for any additional questions, but that's it for the moment.
Okay, thank you. Thank you again, everybody who attended this this webinar. Again, we'll be shooting you guys out a follow-up email with a questionnaire and a link to get your PDH certificates.
All right. Thank you, everyone. Have a great day. I appreciate you attending the webinar. And if you do have any questions, we're going to hang around for about one more minute. All right. Thank you, everyone. Have a great day.
Thanks, Robert. This is Don. Appreciate it.
Thank you.